Morning, guys. So today we're going to take a look at the next step for factoring, or the next idea that we're going to talk about when it comes to factoring. This will probably take a little while for you to get the hang of because there's a lot involved. There's just a lot of steps going on, a lot of moving pieces here. Once you get them down, though, it kind of becomes second nature and you can see how to do this stuff. Now, there's a few ways that we factor, and I'm going to be showing you kind of a way that's just a good enough. It gets the job done for these problems where A is equal to 1, which is the kind that you're going to see on the keystone and the kind that you're going to see primarily for me. However, just realize that when you get through later on and you start looking at some other classes like Algebra 2, some other methods for figuring out how to factor things are going to come into play, and you might need to kind of remember those or go with those. I am absolutely happy enough to show that to you in another video if enough people want to request it. But this method right now, it'll get the job done. So what we're taking a look at is we're taking a look at some quadrilaterals. Not quadrilaterals. We're looking at quadratics. Quadratics being x squared plus something x plus something else. So we have an x squared term, we have an x term, and we have just this constant at the end. Now, normally quadratics, they're going to have this a here at the beginning as well. So it's a times x squared plus b times x plus c, where a, b, and c can just be whatever numbers they want to be. However, for us, for factoring, we're going to look at the case when a is 1. So we're going to take this away. So all of our problems here, they're just going to start with x squared. And then these two numbers are free to kind of be whatever they want to be. And again, when we're factoring something, we're looking for what two things could I multiply together to give me the thing that I had at the beginning. And we saw that with our GCF last week. So for our GCF, we might have had a problem like this: 6x squared plus 12x minus 18. And in this case, we have a GCF. If I want to see the two things that multiply together that give me that, I can take a GCF of 6 out front and then write what's left over. These two things multiply together to give me that top that I started with. What we're going to do now, though, is we're not going to have a GCF because this is 1, and I'm not really going to change the variables around yet. Just know that the first thing you should always look for when you factor is going to be the GCF. We're going to skip that step for now and try to factor something that looks a little bit weird. Let's look at x squared plus 7x plus 12. And you notice there is no GCF here. The GCF is just the number 1, and it doesn't really count, right? If we're going to factor this, the way that I'm going to show it to you is there's these couple steps. First of all, identify the signs in a, I'm going to use this word here, shell. And what I mean by shell is, if I'm going to factor this thing, it's going to factor into 2 binomials. So here's the shell that I'm talking about. Just like we would distribute 2 times, I'm going to have something here at the beginning and something at the end of each one of these binomials. And this is the shell that I'm referring to. And the signs that I'm talking about are, well, what should these signs be? Should they both be plus signs? Should they both maybe be minus signs? Or should one of them be a plus sign and one of them be a minus sign? How can I tell what the signs should be in this shell if I am able to factor this trinomial that has an a value here of 1? Here's how we can do it. We want to look at the sign on C. So we want to look at this sign up here. If this is a plus sign, then we're going to double the sign on B. So if we look at our example, we do have a plus sign here, which means I want to double up on the signs that I see here. So in my shell, I would have 2 plus signs. If it was a minus sign at the end, then we would just have a plus and minus in our shell. So let me erase this here and let's continue this problem a little bit. And you'll see plenty of examples of each one as we keep going forward. Let's fill in our shell. That's going to be step 1. So we have a plus sign on C, which means I double up on the sign that's on the B. I have 2 plus signs. Step 2, we want to take the square root of this first term. I know that when I multiply my first distribution, this first term times the other first term should give me this first thing. So what do you have to multiply to get you an x squared? Well, if you take the square root of this, you'll see that it's just an x and an x. So we're always going to get in the habit here of filling in just these x's, x and x, at the start. This is my shell. I need to know what numbers will go in here, though, as well. And this is where we have step 2. What we're going to do is we're going to factor the C term. So for C term here, we have a 12. I want to write down all of the factors of 12. I'll do that over here. So to get 12, I could have 1 times 12. That's the obvious one. Make sure you still write it. You never know when these things could come up. What else multiplies together to give you 12? We've got 2 times 6, and we also have 3 times 4. And I think that about covers it. These are all the things that can go into 12. For step 3, we want to choose the pair of factors that makes the B term. So look at what B is. B is 7. Do you see any way that we could add both of these things together to get 7? Well, if I add here, I get 13, right? If I take positive 2 plus 6, and again, these plus signs here, they're coming from the fact that I know my signs here have to be plus. So positive 2 plus 6 gives me 8. Well, that's not 7. And positive 3 plus 4 gives me 7. This is the pair that I want. So the things that I should put inside these inside these parentheses, I should have a 3 and a 4. This will be the completed factoring of x squared plus 7x plus 12. And you can always verify it, right? We know how to verify. You just do the thing that it says, kind of go back through. We would double distribute. X times x gives you x squared. X times 4 gives you 4x. 3 times x gives you 3x. And 3 times 4 gives you 12. Combine your like terms, and you see that we're back with the thing that we had at the beginning. This is one way that you can check to make sure that you factored it the right way. So let's go through these motions for a couple more problems here to really solidify the fact that we know what's going on. So our next one, let's factor g squared plus 7g plus 10. If we're going to be able to factor this, first look for a GCF. We don't have one. Great. So now we move on to our shell. Inside my shell, what signs should I have? Since I have a plus sign here, I should have 2 of whatever sign this is. So I'll have 2 plus signs again. At the beginning of each one of these, I want the square root of whatever I've got at the start. So to make g squared, I would have g times g. Step 2, I want to factor the c term. So we'll take 10, 1 times 10, 2 times 5, that's it for 10. Of these, when I have two plus signs, which one gives me 7? The 5 and the 2 gives me 7. So I can put a 2 and I can put a 5, and it doesn't matter what order you put those in. For this one, I could have put the 5 first and then the 2, doesn't matter. This is going to be the factored form of g squared plus 7g plus 10. How about one with a minus sign here? Let's do d squared minus 17d plus 42. GCF? None. So move on to the shell. The signs inside my shell, if I look at my C term, it's a plus sign, so I want to double up on the signs that are on the B term. That's a minus sign. So I have two minuses. At the beginning, I'm going to have d and d to make the d squared. And then I want to write down the factors of 42. Factors of 42 are going to be 1 and 42, 2 and 21. I think 3 goes into 42 14 times. And then we've also got 6 times 7 gives you 42. If you're not sure how to come up with all of these factors, just take your original number and just start dividing through the number line. If you get a whole number as a result, then it's a factor. So if you take 42 and you divide by 3, you get 14. But if you take 42 and you divide by 4, you get some decimal number. So it wouldn't be a factor. Now of these, which ones can I put minus signs on that would make me a negative 17? It's certainly not the first one. Doesn't really look like this one. This one gives me negative 23. The third one gives me negative 17. Negative 3 minus 14. So I want a negative 3 using that minus sign that I already knew had to be there, and I want a negative 14. This would be the factored form of d squared plus 17d plus 42. And let's finish this off with one more using the other set for the shell. Let's factor y squared plus 6y minus 27. Again, there's no GCF here. We don't have to worry about that now. You will soon, don't worry. And if we look at our shell, to figure out what signs go in here, I look at my last sign. And because this is a minus sign, I know that I need a plus and a minus. That was the rule. If this is a minus sign, I need a plus and minus. As a matter of fact, it doesn't even matter what this sign is. As long as this one on C is minus, it's got to be plus minus or minus plus. Doesn't matter the order. We're multiplying, right? Fill in the thing at the beginning. I've got a y squared here. So to make that, we do y times y. And we keep following the same steps that we did before. Write down the factors of your C term. So for 27, I've got 1 times 27. 2 doesn't go into it, but I think 3 goes into 27. 3 goes into 27 9 times. So 4, no. 5, no. 6, no. 7, no. So that's it. Now of these terms, notice I got a plus and a minus sign. Which ones can I put the plus or minus sign on to make me a 6? Definitely not the 1 and 27. I have no way of doing that. If I put the minus sign here on the 1 and the plus on the 27, I don't get 6. I get 26. And if I do it the opposite way, where I have the plus on the 1 and the minus on the 27, now I've got negative 26. So I don't want that. But the 3 and the 9 I could use. Which one has to get the plus sign and which one has to get the minus sign? These ones are a little bit more difficult because you have to think about which one of these numbers goes with which one of the signs. In the previous examples, it didn't matter because they were both positive or they were both negative. Now it does. And if I want a positive 6, then I want the bigger number here to get the plus sign. So that I have negative 3 plus 9 gives me positive 6. So the negative has the 3 and the positive has the 9. And you can always, double distribute and check. But we would have y plus 9 and y minus 3 as our answers. Now, one of the easiest, or not easiest, one of the tricky kinds of problems here, and you could see this with more types of problems as well, but one of the trickier ones has to do with the number 6. So let's take a look just real quick at x squared. We're going to do a minus 6 here at the end, and we're going to have a plus, what do I want, a 5? No, let's do plus 6 and a plus 5x here. I think this one will kind of demonstrate it here a little bit better. What I mean by this has the potential to trick you a little bit. If I want to factor this, follow those same steps. You're going to have an x plus and an x plus, because again, our signs tell us that we should have pluses and plus. That's a plus sign, so double up here. If you factor 6, you're going to get 1 and 6, and 2 and 3. Which one of those can I make 5 from? Well, you can make 5 from both of them. You can make 5 from 1 and 6 by doing 6 minus 1. That gives you 5, but that's the trap that you're going to fall into. We don't want that one in this case, because I know that my signs have to both be plus. So if I use my plus signs on both of them, I don't actually get 5 here. I get 7. I only get 5 from the 2 and 3. So just be aware that you might get the thing that you're looking for using multiple sets of these factors, but only one of them really is going to be the one that you want, because it's going to match up with the signs that you know that you want. So this is just our beginning method. This is one way that you can do it for simple problems. If things get a little bit more complex, you have factoring by grouping, which is my preferred method. Don't worry about it though. Wait until Algebra 2. For now in Algebra 1, this will get you through everything that you need. Thanks, guys. Hope this helps with our assignments for the week. And please feel free, stop in on Zoom or just email me if you have any questions.